folks, welcome back to another video. Today we're looking at question 1022, sum of root to leaf binary numbers. The way we'll be approaching this problem is by using recursive calls. Whenever it comes to binary questions, most probably the solution is to use recursive calls. So how would we approach this problem? The way we'd be approaching this problem is by calculating the value that we have so far and going to the next nodes and updating the value again. So let's call a helper method. So let's call it helper. Let's pass in the root, and then the initial value that it starts off with is 0. And then let's actually create the method, the helper, and then it takes in the node, and then you have the value itself. Let's call it int val. So let's check the base case first. So if node is equal to null, we would just return 0. If not, the current value that you have, you would multiply that by 2. And the reason why you're doing that is because you're looking at the second level, but the previous level has to be multiplied by 2 because that's how binary numbers work. So you multiply that by 2 and you add the current value. That would be node.value. And now you have to make a call. You need to decide whether you need to return the value as is. That means we have actually reached all of the leaf nodes and we have calculated everything, or you need to check if you need to recall that method, which is the helper method. How will we do that? We know that we've reached the leaves if both of the current node that we're looking at, the left and the right node, are both null. So if node.left is equal to null and node.right is equal to null, we know that we have finished computing everything, and you would just return the value. If not, you would call the methods again on the left and the right node. So that would be helper node.left, and then you'd pass in the updated value, and you would add that to the right value dot right, and then val. Awesome. So let's compile this and see if this runs okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. The time complexity of the entire solution is O of n because you have to iterate through every single node at least once. And the space complexity is O of h because you're calling it recursively, and you need to keep a stack, like a stack call. So there's a reason why it's OH. Awesome. So if you have any questions about the solution, please let me know in the comments below. Please don't forget to subscribe. I would really, really appreciate that. And like the video. I'll see you all in the next video. Peace.